that came out about 6 months ago called Extraterrestrial that you can see in the middle. And if I had to summarize it with one sentence, I would say, when you're not ready to find exceptional things, you will never discover them. This was the subject of a Scientific American essay that I wrote half a year ago. And you can find my weekly essays in Scientific American on my website. I also published a book that you can see on the right side. Sorry, there is someone speaking.
And I'll try to mute. There must be. Yeah, you can go on, Professor. Yeah, sorry.
A book that I published with a colleague of mine, a former postdoc of mine, Manasvi Lingam, which is a textbook, 1,000 pages long, that you can see on the right side, Life in the Cosmos. And that is meant mostly for practicing scientists, that it provides an updated overview on the subject of the search for extraterrestrial life, both primitive life and intelligent life. And what you see on the left side is a photograph of a photograph that was taken by the German photographer Herlinda Quilbel, and was exhibited in Berlin in October 2020. And she asked me to write on the palm of my hand the most important question that I can think of in the context of science. And I wrote, "Are we alone?" Now, about a month ago, we announced the Galileo project, and the goal is to answer this question by using telescopes, searching for relics of other intelligent civilizations in our vicinity. We launched the Voyager, New Horizons, and other spacecraft, and most stars formed billions of years before the sun. So it's quite possible that there was a technological civilization that predated us by 1 billion years, and then it would have sent equipment into space, and some of it may be close to us. Especially if you think about artificial intelligence, you can imagine equipment that is autonomous, that learns from experience, that outsmarts people. And we cannot just assume that we know the answer without looking through our telescope. That was the mistake of the philosophers during the days of Galileo that claimed that the sun moves around the earth. They knew the answer, but they were wrong. And the key is to look through telescopes to find the answers to questions. And in this project, we are planning to get high resolution images of 2 types of objects, unidentified aerial phenomena that were included in a report that was delivered to the US Congress on June 25th. What we would like to get is a megapixel image of such an object whose nature is not clear at the moment. And at a distance of 1 mile, that would allow us to distinguish a label saying made in country X here on Earth from made on exoplanet Y somewhere else. And then we plan to also search for objects that came into the solar system from outside that do not look like a comet or an asteroid, and learn more about them by getting a close-up photograph or tracking their trajectories. So this is the Galileo project. I'm just skipping a few slides because a lot of time. And my basic premise is that of modesty. I call it cosmic modesty because we know that about half of the sun-like stars that look like the sun, have a planet roughly the size of the Earth at roughly the same separation. So that means that not only we are not at the center of the universe, as Galileo concluded, it's also true that what we find in our backyard, the Earth-Sun system, is not special. And therefore, if you replicate the same circumstances, you might as well get similar outcomes. And it turns out that in the observable volume of the universe, there are more habitable Earth-like planets than there are grains of sand on all beaches on Earth. And it's very arrogant of us to think that we are special and unique. And you can see here an emperor that was very proud of himself because he conquered a piece of land on Earth, but that's not more impressive than an ant hugging a single grain of sand on the landscape of a huge beach. So we should adopt the modesty, but I can understand where the arrogance come from, because when my daughters, you can see them in the picture, when they were very young and they stayed at home, they thought that they are the smartest in the world. And the only way they change their opinion is by going to the kindergarten and finding other kids and realizing that other kids may have better skills. And so our civilization will mature only by leaving home and meeting others on the cosmic street, so to speak. And there are good reasons to think that we are not the smartest kid on the block. If you just open the newspaper or you look at human history, you realize that much of the time was spent in people trying to feel superior relative to other people. And that makes little sense if there is a smarter or a more intelligent civilization out there, because we are all part of the human species and our differences are really insignificant. So I really think that we are most likely an ant among many ants that predated us on the pavement, on the sidewalk of the Milky Way galaxy. And of course, Earth currently is our home, but only for a while, because there are all kinds of risks that we face, either associated with our environment, that we are causing changes in through climate change, potential wars, pandemics, political and technological catastrophes, but also external threats from asteroid impacts, and eventually the sun will boil off all the oceans on Earth within 1 billion years. So just to give you a little bit of background, I mean, how did I get to think about space and going to space? I was born on a farm in Israel, and you can see me on the top left as a kid. I used to collect eggs every afternoon and drive a tractor to the hills of the village and read philosophy books. Philosophy interested me the most because it addresses the most fundamental questions. But of course, we don't have answer to most of them. And then eventually I got to Harvard, and what you see on the bottom left is a visit that an entrepreneur from Silicon Valley, Yuri Milner, came to Harvard and offered me the opportunity to lead a project whose goal is to visit the nearest star within our lifetime. It's called Starshot, and we inaugurated that project in the company of Stephen Hawking. You can see it in the middle bottom panel. So that's in terms of coming from a farm and exploring space, going to space. This is a picture of the solar system. You can see the sun on the left. And in fact, the solar system continues halfway to the nearest star. There is the so-called Oort cloud that includes all the building blocks, the bricks that were used in the construction project of the planets in the solar system. And the Oort cloud goes halfway to Proxima Centauri, the nearest star, which is 4 light years away. So it takes light 4 years to travel the distance. And there happens to be also a habitable planet, a planet just at the right distance to have life potentially on its day side. And the question is how to get there. And the technology that I proposed to Yuri Milner is that of a light sail, where a very thin film of material is pushed by a powerful laser, 100 gigawatt in power, that shines on this film that weighs roughly 1 gram for a few minutes. And that would bring it to 1/5 of the speed of light across a distance that is 5 times the distance to the moon. And this technology can launch a spacecraft at a fraction of the speed of light. So it would take 20 years to get, for example, to Proxima Centauri. And one can equip the light sail with electronics. So the light sail is just like a sail on a boat. It's pushed by light, by reflection of light, rather than the wind. You can think of the particles of light, which are photons. You can think of them as tennis balls that bounce off a racket when you play tennis, and you feel the push from the tennis ball. And in much the same way, particles of light, when they bounce off a surface, give it a push. So this is the illustration of the technology, where a lot of small lasers combine to make a very powerful laser beam, and the sail is released above the atmosphere so that it will not encounter friction. And then the powerful laser beam goes through the atmosphere and pushes on the sail for a few minutes, and it reaches a fifth of the speed of light. And on the sail, there is a camera, navigation device, communication device, and it will take 20 years for this spacecraft to reach the destination. It's a very boring journey. Most of the time, space is empty. And then once it gets there, it could take a photograph of the planet, potentially informing us with these photos whether the planet has life on it. And of course, the signal from the camera that will be beamed back to Earth would take 4 years to reach us. So it's a very long time altogether, 20 years for the journey plus 4 years for the signal to come back. So a quarter of a century or so. But that's the nature of interstellar distances. They're very vast. So, and the fundamental question, as far as I'm concerned, is not just whether there is life, let's say, on the planet next to Proxima Centauri, but are we the smartest kid on the block? That's the interesting question. And the best way to find out is to be open-minded and search for evidence, not to have a prejudice about this question. And the first place to look is actually in our backyard. In 2017, a telescope in Hawaii called Pan-STARRS discovered the first object that came from outside the solar system that we discovered close to Earth. And it was given the name Oumuamua, which means a scout in the Hawaiian language. You see it circled in blue here on the background of stars, and it's moving relative to the stars, of course. And this object, this is a sky map of where the object came from. Turns out that it came from a very special frame of reference, which is called the local standard of rest. That's the frame that you get to when you average over the motions of all the stars in the vicinity of the sun. It's sort of like the local galactic parking lot, and only 1 in 500 stars are at rest in that frame, and Oumuamua was at rest. So it was clearly not, it didn't come from any of the nearby stars. And it's not clear why it was in that special frame. It was a weird property that it had. And then, I mean, you can think of it as a buoy sitting at rest on the surface of the ocean, and then the solar system bumped into it and gave it a kick, just like a racket giving a kick to a tennis ball. As the object was tumbling every 8 hours, the amount of sunlight that was reflected from it changed by a factor of 10. And that meant that it has a very extreme shape, most likely flat, pancake-like. And it had some other strange properties. There was no cometary tail. There was no evaporation of gas or dust from this object. So it was definitely not a comet. And in addition, it exhibited an excess push away from the sun as a result of reflecting sunlight, most likely. And since there was no evaporation of gas, I suggested that it's not the rocket effect, but rather just the reflection of sunlight that gives it a push. And for that, the object had to be very thin, similar to a light sail. And so I suggested in a scientific paper that it may be artificial in origin, not natural, not a rock. And since then, there were several proposals by mainstream scientists that tried to explain it as a natural object, but all of them suggested something that we've never seen before. For example, there was a suggestion maybe it's a cloud of dust particles, very lightweight, so it's pushed by reflecting sunlight. And the problem with that is if it's 100 times less dense than air as you need it to be, then it will not maintain its integrity. When it comes close to the sun, it will get heated up by hundreds of degrees. And then there was a suggestion, maybe it's a chunk of frozen hydrogen so that we don't see the evaporation. And the problem is that a chunk of hydrogen the size of a football field was never seen before. And also it would not survive the journey between stars because it will get evaporated by absorbing starlight. Then there was a suggestion, maybe it's a nitrogen iceberg that was chipped off a planet like Pluto. And the problem with that is the mass budget. There is just not enough solid nitrogen to account for enough chips such that we would see one of them over a period of a few years, as Pan-STARRS did. And since then, there was also a report delivered to Congress, as I mentioned, in which there are unidentified aerial phenomena. And these are presumably objects whose nature is not known. And the US government says that the reason they believe these are real objects is because they were detected in multiple instruments, infrared sensors, optical cameras, radar systems, and many pilots saw the same thing doing the same thing. And it's unclear what these objects are. They behave in ways that do not replicate our technologies. And so at that point, I thought that it makes sense to establish a project that would, whose goal would be to identify the nature of these objects and also the nature of Oumuamua-like objects. And that's the Galileo project. It will get scientific data that will be open to the public, and the analysis of it will be transparent. So the experience of seeing Oumuamua in particular, and that's what my book, Extraterrestrial, focused about, the experience is similar to walking on the beach. Most of the time you see rocks, but every now and then you see a plastic bottle. And that implies that there is a civilization out there. And since then, since the discovery of Oumuamua, there was another object discovered in September 2020, and it was given the name 2020 SO, also discovered by the same telescope, Pan-STARRS. And this object exhibited an excess push away from the sun by reflecting sunlight, no cometary tail, just like Oumuamua. But the astronomers that discovered it realized that actually it came from Earth. In 1966, there was a rocket booster that was launched in a lunar lander mission, and this was the rocket booster. So we know that this object has thin walls, and that's why it has a large area for its mass, and it was pushed by reflecting sunlight. So we know it's artificial in origin. And therefore, the question is, we produced this object, who produced Oumuamua? And we don't know. Let me skip that. And the fundamental question is whether Oumuamua is natural or artificial in origin. And of course, the best way to find out is to take a close-up photograph, because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book. I wouldn't need to write the book if we had a photograph just like this one that was taken by OSIRIS-REx of the asteroid Bennu. When this mission landed on Bennu, it will bring a sample of the rock on the asteroid Bennu to Earth in 2023. I'll skip some slides. Now, in principle, in addition to finding relics from other civilizations, which I call space archaeology, we can look for other signatures of technologies. For example, we can look for industrial pollution in the atmospheres of other planets. We can look for artificial lights that are not naturally produced. For example, on the planet next to Proxima Centauri, we wrote a paper about that with a student. We can look for beams of light that are used for propulsion, like light sails. And we can look for, for example, for photovoltaic cells on the day side of planets that are used to produce electricity. They have different reflectance than rock. And we can look for satellites, for example, surrounding planets. In principle, you can reach the speed of light not just with a laser beam, but also if a star explodes, there is a flash of light. And if you park light sails in the vicinity of the exploding stars, you can get close to the speed of light just by the push you get from the flash of light. That's just like being a surfer in Hawaii and surfing on a wave. So Enrico Fermi asked this fundamental question, where is everybody? And it's quite likely that most of those civilizations are not around anymore, because there is just a short window of opportunity for us to communicate with them, for example, by looking for radio signals. But we can do archaeology, space archaeology, to find artifacts of other civilizations on other planets or if flying in space. And my hope is that if we find such relics of civilizations that are not around anymore, we might figure out why they're not around anymore and perhaps get our act together and avoid a similar fate. Thank you.